once again, good evening, everyone. My name is Michal Slaski. As you can see in the bottom of the slide, if you would like to follow me on Twitter, here's my Michal Slaski tag. And today I will talk about a chat feature. A chat feature. This is a text-based communication. This is probably one of the first use cases for the internet. Send a message, text message, to the other person. So we had some first messengers in the early days of internet, or actually systems, like Talk, IRC, ICQ. So this is how we looked like some years ago. But then all of the technologies evolved. We have now some modern messengers, which look nothing like the ones from the old days. They still deliver the text communication, but we also have voice, video, file sharing, and all sort of other features that you can think of. So this is how the modern messenger could possibly look like. So it has lots of other things in it, not only text. Still, the principle, the use case for it is to communicate. Now, what also has changed over the years is that those messengers are now run on mobile phones. They use mobile networks, 2G, 3G, LTE, and they support mobile workers. So you get on a phone with someone, then you actually switch to your laptop, then you're again on the move for a lunch break, but you continue your conversation again on your phone. So you switch devices, you switch computers, but this is still the same conversation, which is continuous. So this is what I call a mobile worker, someone who is walking around, maybe switching cities or countries, but he is still working. Can anyone spot some pattern here? Is there any common thing here? Anyone?
Mobile.
Yes! Mobile. Good. Yeah. Well spotted. Well done. Mobile. So is it any different from those messengers that we had on our desktops some years ago? Yes, it is. And now this theme for today is to first explain what are the challenges of the mobile messengers. Also, how mongoose is trying to address them. So if you have mobile phones, it means that it has less power, typically, when a web browser running on your desktop. If you are on a mobile network, it means that this network is noisy. It means that sometimes you will drop packets. Not everything will be delivered. Also, the latencies will be much higher than if you are connected through broadband connection. If you are a mobile worker, it means that you want to switch devices. When you're going for lunch, you're not going to carry with you 13-inch laptop. You will take your iPhone with you or some other mobile device. And the other way around. If you entered an office and you were having some conversation on your phone, you want to actually switch over to big screen and start using your laptop. And yet we want to deliver a seamless experience on all of those devices throughout the day. Those are the challenges. How to make it all happen. Networks, small devices, mobile workers. Before we go into how to solve it, I need to introduce also a few concepts around XMPP. XMPP is a protocol which is used for messaging. It has been invented many years ago, when XML was actually popular. It is not nowadays, but at the time XML was the way of encoding things, and also it was solving some issues of desktop computers, of connected through broadband connection. So XMPP 10 years ago was nothing what it is today. It was trying to solve messaging problems of people developing messengers 10 years ago. In short, XMPP is open standard, so you can go to the xmpp.org website and read about it. There are some RFCs published which describe what it really is, what is the core. It's secure, meaning you always have to authenticate your users. And so this is nothing like email, where anyone can send anybody any message, anytime. Here, actually, you first log in users to this XMPP network. You authenticate them. Then you authorize them to send a message. So there is no spam, or at least not as much spam as in email networks. It's flexible. Being based on XML, you can actually build new features, custom extensions, custom behaviors on top of the core, which is defined by RFC. It's decentralized, meaning it was designed to power, well, world networks. So it's not like there's one central operator who's providing the XMPP service worldwide. Instead, you can run your own XMPP server at your home and then connect to others. So it's a decentralized protocol and network, which is actually good because it can scale much better. And also it can cater for different needs. And it's proven because it has been around for more than 10 years. It was used in many commercially successful projects. So this technology has been already proven. Now, the issue is that the XMPP protocol was defined some years ago, as I explained, when there was no mobile phones, networks, workers. But I said it's flexible, and indeed it is. The XMPP Standard Foundation, which is the body which is trying to establish some well-discussed standards which are proven and that are trying to explain how to solve certain patterns, we call them XEP, XEPs. So through enhancements, through those XEPs, the XMPP community was trying to work around the new challenges arising from mobile. And a number of such extensions have been developed over the years. Some few years ago, the XMPP community was quite comfortable with it. And it was quite realistic to say, yes, XMPP can now support mobile use cases. The only issue is that now, once the standards are online and published, others have to adopt standards. There are many different XMPP server implementations and client libraries out there. And as you can imagine, with anything which is open source and open standard, the level of support for different XEPs in different servers or client libraries will be different over time. So this is not like all XMPP open source servers support all of the XEPs which power mobile. Fortunately, mongoose IM does. In 2014, we've been working on bringing support for the necessary XEPs to mongoose IM, and those are the stream management, which is XEP 198. This one ensures that even if some portion of the traffic got lost because you just entered an elevator or you disappeared in a tunnel or actually in the forest, there is no reception anymore, those packets, even though not delivered, will never be acknowledged. So later you can try to retransmit those packages that were not delivered. We call it stream management. So we manage the stream of those messages flying from server to client and from client to server in a way which gives us full control over acknowledging that certain portion of the traffic got delivered or not yet.
So does the device know it missed stuff, or does the server know it hasn't
Both
been
ways.
acknowledged?
Both ways, because both the device and the server expects the other end to confirm every once in a while, I got it,
Yeah.
I got
But
it.
if the device never received the star, it doesn't know something was being
But then the
sent.
server will have a timeout
Okay.
behavior.
Yeah.
So server will say, hey, mobile,
Yeah.
did you get it?
Yeah.
I'm waiting, no response. You will consider this mobile to no longer be online and you will cut him off. So next time he actually wakes up, because it just happened that it took him longer to get out from the elevator when your timer was set on the server side, what we can do is we can resume a session.
Where I live, that might be 3 days later because I don't get any data.
So then you need to log in again. So then you need
But I
to...
don't want to receive the messages I was sent 3 days ago.
Oh, you want to or you don't want to?
Well, I've got to make a choice. Maybe I do, maybe I don't.
Okay. So what we do is, to be on the safe side,
Yeah.
we will store a copy of all the messages that someone was trying to send you when you were offline, so that when you get online, we can stream all of this.
Yeah.
But this is a different extension. I'll talk about it shortly. But just to sum up, the stream management one is about making sure that even if some messages are lost, and they will be lost, for sure, we can manage this situation, and in a quite efficient way, traffic-wise. So this is one concept that we introduced. Another one, it's called message carbons. And this is the case where you have several devices. So I happen to carry this iPad with me, there's my MacBook here, and then I have my Android in my pocket. What if I would be running some messenger on all three of them? We need message carbons, which means that we will actually deliver a copy of each message that I'm sending out to the other devices, so that the experience, the view of a conversation is consistent across all the devices, right? So message carbons is about supporting multiple devices of the same user, which is quite often the case nowadays. Then message archive management is more about storing a copy of the message. So this actually gives us two things here. One, whatever you want to explore, like 5 days later, it's possible thanks to the archive, because you can actually browse all your archive as deeply as you need. So this is about storing a copy of all messages that you received and you sent in some huge database. But it's also about syncing devices that were disconnected for some time. So for example, I had my laptop turned on all day long, but my phone ran out of batteries. So when I charge it and turn it on again, it's not that I missed any message, because I actually had a chance to read them all on my laptop. But now, to make sense of a conversation, you actually need to see all of those messages that in the meantime were delivered to my laptop, actually to respond, right? And this is the archive management again. We will sync my mobile so that this is up to date, as is my laptop.
Does it have the notion that you've read a message though? Because if I've read it on my laptop, I don't want to have to read it again on my phone.
Advanced message processing is an answer to the question.
Yeah.
So this one is about syncing, or well, exploring the archives, and some notifications about the status. This is supported by XMPP 79. So indeed, there is, because it's quite hard to say today, what does it mean that someone is present? What does it mean that you're online? You are always online. If you are not on this one, we will reach you through push notifications.
I'm still not sure if this is just software you're offering or if you're offering a service.
We are talking here about an open source server side. I will get to the point what mongoose really is shortly. I'm trying to give you some background here for messengers in 2015, the challenges, and the next slides will try to explain, so what is mongoose and how does this fit the picture?
So it's free and open source software.
In short, yes. So those were the new things that we introduced. Another thing that we also have been working on was to make sure that whatever we introduce to mongoose IM does scale. Because it's not only a matter of adding new features, this is reasonably easy, but it's also about being able to support them later. What does it mean to support a feature in the modern messenger? It means that it has to scale to millions of concurrent TCP connections, where each TCP connection represents one user session. I'm just one human being, but it's quite likely I will generate 3 TCP sessions with the server from my laptop, my tablet, and my phone. So imagine we have 100,000 users, we actually need to be able to support 300,000 TCP connections. And for every feature that we support, we need to be able to, well, to sustain the traffic that it can generate. So for every test that we perform, like functional test, we also perform some load test. And this is extremely important.
So are you going to be talking about the kind of the horizontal scalability of mongoose things? How you do it?
Not today. If you would be interested, the question is whether I will be talking about horizontal scalability of mongoose IM. I'm happy to discuss this. We can discuss this through you asking questions, me trying to answer them, or later when we each grab mongoose IM beer and have a pint. So one way or another, I'm happy to discuss this. But the theme of this slide is about mobile challenges and how we address them. Okay?
As you start to hit the constraint of TCP connections on an underlying Unix system, you start to hit the limits as to quite what that can do on a single server, and therefore you've got to scale across horizontally onto multiple servers in order to be able to accommodate in any reasonable number.
Yes. So what we are seeing here, which for those of you who cannot read it really, is that we are counting number of concurrent sessions on a cluster. So this is already a cluster of several mongoose IM nodes, and this is why we can support almost 1.5 million connected users. Actually, frankly speaking, you could fit all of them on a single box if you would only have enough RAM. If you see some of
What is enough?
what is enough? Sorry?
What is enough RAM?
What is enough RAM? More than 100 gigabytes to support millions of users per box.
Yeah, you start to hit issues on Linux. I get really nervous with Linux going much. Maybe 500,000, a million you can do. WhatsApp claim they've got to 2 million.
Free.
On FreeBSD,
Free
3 million, but they're running FreeBSD.
Correct.
It gets difficult as those numbers. You really don't want to get to those upper limits.
You're right.
Better to scale horizontally.
Yes. So we can scale vertically. This is thanks to the Erlang virtual machine, which can leverage multi-core
Erlang scales
processors.
really well vertically.
Yes. So we leverage Erlang for the vertical scalability, and then we leverage Erlang for the horizontal scalability. Because actually Erlang VM supports both the SMP, but also distributed Erlang. So this is just I'm not going to discuss load testing in details today, because it's a broad topic and it deserves another user group meeting. But I'm just saying here that last year we've been not only adding features, but also testing a lot to make sure that this does scale. So when we test, we not only see how many users we can connect, because this will be dependent on RAM most of the time, but also how many messages we can push through the system. Because now it's not only about the message traffic, so the network traffic, it's also about the database I/O. If we're talking about the message archive management feature, which stores a copy of each message in an archive, in a database, we need to sustain throughput of, let's say, 100,000 messages per minute to be written to a database. It's okay, I mean, quite a lot of databases nowadays can support this number, so it's not a challenge, but we need to ensure that actually this does support this many writes per second or per minute. So we also run them. And then we actually start to hit some limits of the infrastructure of software, of other things. And then we also observe through metrics, so where did we underperform? So here you can see messages dropped per minute. So during load tests, it's not good enough to say, okay, we pushed 1 million messages and we had 1 million users. We also need to measure very many other things. Things like, how many of those messages had to be dropped? What were the latencies? I mean, what is the joy of sending somebody a text and then waiting 15 seconds to get this delivered? Today, users expect that the system will deliver a message within seconds, if not milliseconds. 15 seconds? I'm going to change a messenger. So it's also about latencies. I don't have a slide here. We have contributed some patches and extensions to the Zoom load testing tool, which also helps you measure the time to deliver a message, which is quite important, because this also shows whether the system is actually still performing according to some SLA, or it's already overloaded. So it feels like you can have 1 million users, but in practical terms, the experience is way below their expectation. So this is also important. Anyway. We believe that with those feature sets that we added to Mongoose and with the fact that we can scale to millions of online users, we are actually ready to offer Mongoose IM as good solution for mobile networks, for mobile messengers. We are planning on adding some more features like support of JavaScript. Of course, you can do it already today, but we want to enhance this experience, add more database backends to the message archive feature, and prepare Mongoose IM for web of things. In other words, today it's easy to use Mongoose with XMPP protocols. We would like to make it easier to use it with some web frameworks, whatever web means. But here's a summary of what Mongoose really is. It's an instant messaging solution. It's an open source XMPP server implementation, which has been adopted and installed in different solutions throughout the years. Social media, gaming, telecommunication. So think about in-game chats, when users have to coordinate some actions they take in a gameplay. You have an in-game chat to facilitate communication. Or social, I mean, I don't think I need to explain to anyone what messengers are as far as social life is concerned. WhatsApp being a good example, and many others. Telecommunications, like where you actually need some signaling layer to enable video calling, audio calling. This can be powered by XMPP, Mongoose IM. And as this solution has been designed for high volume, this is what makes Mongoose IM.
So, are you going to be telling us anything about what that design looks like? You know, given a slide showing you as performance, but I think as software designers, we're kind of interested in, okay, well, how have you achieved that? What's the architecture? What's the design look like in order to achieve that high volume?
I don't have a slide which would give you like a big picture of the internals of Mongoose IM. We can discuss this in general terms, I think. How many of you are familiar with Erlang programming language? Almost everyone. That's good. I will try to address this question. Let me just summarize what Mongoose IM is, and then we can dive into some interesting details. So I will be then open for questions. I already have one. And so think about other questions that you may have, so we can then spend the second half of this meeting discussing rather than me telling you a story. To finish the story, high volume is important because once your messenger, your solution, your application is successful, it is a matter of weeks that you will be getting more and more and more traffic. So we need to scale, and this is why mongoose is a distributed system. So it can scale also horizontally. We've been running mongoose on hosted solutions like Rackspace, for example, on cloud environments like Amazon. So it can scale on different platforms and leverage Erlang distributed features. And because of the support for those features I described, we believe that this is suitable for modern mobile messengers. If you want to grab mongoose, you need to either visit our website, where you will find the products session, and in products, one of them is mongoose. This is where you would also get some high-level overview of the architecture. There's some collateral material about the features. There's also a number of webinars that we gave in the past that have been recorded and are published, so you can learn how big solutions have been designed. For example, a webinar with Uwu, chief architect, was given some time ago, where I have described, together with Alex, what was the architecture that powers Uwu system, where they have cluster of clusters of mongoose nodes. So it's distributed across several data centers with many nodes running in smaller clusters, all combined together, support their huge database of users. So webinars might be also answering some of the questions that pop now, okay? Or you can go to our GitHub account, because the good news is that this is for free. This is an open source project. It's of course not like really free, because then you need to spend some time, for example, downloading it and installing, so this will consume your time. But in order to get started, to test it, to start to prototype, we are trying to lower the entry cost as much as we can. Meaning we publish a lot of those extensions as open source, to give you a chance to try to experiment mongoose as a truly open source project. And this is also how I would like to invite you to communicate with the team. If you will find this solution interesting, we will have some issues, questions, maybe contributions. Try to collaborate with the team through GitHub. There are issues, roadmaps, comments, wiki pages. This is truly an open source project. So we try to maintain an open source culture around it. And this is how I would like to see further discussions once we will, well, leave the room. Now, to answer the question about architecture, it is based on two simple ideas. One, keep all sessions in a hash table. So it's a huge hash table of Erlang, we call it ETS, where all sessions are stored, as in a mapping between your address, which looks a bit like an email address, and process PID. So for each user session, we have one Erlang process, which is identified with a process identifier PID. And we have a huge hash table which maps.
So how do you tie together when a user has multiple devices? Are you using an agent-based architecture there, where each agent talks to the multiple devices owned by a user, or are you managing those as separate endpoints and somewhere else maintaining that relationship?
So are you familiar with GID notion? No?
Yeah.
Yes? Okay, so GIDs have resources.
Yeah.
So like the per GID looks like my email address, and then after slash you would also have this extra bit which can differentiate between several user sessions. So I'll have 3 sessions, it means I will have 3 resources, which means I will have 3 entries in this global hash table. And now when I want to send a message to a particular device, I can use full GID, which includes the resource, which will pinpoint this exact TCP session. If you have message carbons or some other techniques, you may want to deliver the message to their GID, which is anyone connected with this username, no matter what resource.
Yeah, so that sends it to all devices.
Yes. Now, thanks to this is one concept is as simple as this, which is huge global hash table, and second is leverage Erlang distributed protocol.
Now, you said you're storing that hash table in ETS.
Yes.
Doesn't that impact your scalability?
Yes,
Because
it does.
ETS is only within that individual node.
No,
You're
it's
not
global.
using
It's
amnesia.
synchronized across all the nodes.
Okay. You're not using amnesia to synchronize.
We use Amnesia to synchronize.
Okay.
So actually, I was simplifying, saying that this is a huge hash table.
Yeah.
I should have said this is a RAM-only copy of an Amnesia
Yeah.
table.
Yeah.
So what's the maximum number of nodes in a cluster there?
I mean, in practical terms, we typically recommend dozen of nodes, so like 10, 15. Beyond this number, we will suffer from randomness in networks, from failures, from maybe some splits and such. So we typically advise 10 to 50 nodes per cluster. If you need more, then as in the UVU webinar, there's cluster of clusters that you can build, which will scale to much higher numbers. And UVU, for example, as far as I remember, is running something like 60 nodes in total.
Are you hitting anywhere the 2 gig limit on the amnesia tables?
It's RAM only.
But you still hit the 2 gig limit on a RAM-only copy?
No.
Yeah, you have to fragment it.
No.
You don't?
No.
Is depth?
No, it's ETS.
No,
ETS,
that's
Erlang
different.
term storage. It's the RAM only
Okay.
copy.
Yeah.
It does not
Yeah,
get the 2
okay,
gigabytes.
so you're not backing it off anyway. It's RAM-only copies on every
No,
node.
we are not. This is transient
Yeah,
data.
yeah.
Once the user is gone, it's gone. Once the node is gone on which the user had the session is gone.
So
this is-
somewhere else you must be persisting that message, because you were talking about having persisted. Oh, well, that's just the session data in amnesia, isn't
I mean,
it? So
session
somebody
data
got
is
message
something
data.
which allows us to deliver the message
Yeah,
to the box
yeah.
which has the TCP session. This is all it has. Now, all the rest, which is I don't know, the roster, present subscription list, all these things, this is stored on the node within the process which is responsible for the user session. So, in other words, yes, we scale. The limitations of mongoose IMS of today are related to Erlang distributed and RAM copy of Amnesia. So we are limited by RAM and by Erlang distributed protocol. We are working on a new generation of mongoose IM, which will scale beyond the numbers that we currently can offer within a single cluster. But this is in the making, so there's not much to discuss today.
Have you looked at S groups and things like that?
Sorry,
Have you looked at S groups?
I'm not sure what is S group.
It's the OTP branch from the release project.
Oh, the scalable Erlang.
Yeah, so they allow you to partition an Erlang cluster.
Yes, so I'm familiar with the
Get
concept.
much more scalability that way.
The question is about have we tried this scalable distributed Erlang, and so I'm familiar with the concept, but we did not try to apply this concept to mongoose IM. We see some other opportunities to scale.
Yeah, I think you only need it when you get into the hundreds of nodes. I think if you're down in the tens, you're okay. It's when you get in the hundreds that you really need to partition the cluster.
Yep. So did I answer at least some of your questions related to
Yeah, one more there. What's the back end where you store in your message database? Is that
Depends on
React,
what
or
you-
is that? Okay.
Depends
Or it
on
can be
what you
anything.
need. So in the open source version, we support Cassandra, Amnesia, I think MySQL or Postgres. So we are supporting some of those, and support for others will most likely be made available in 2015. For example, support for DynamoDB. We are considering releasing support for DynamoDB.
And we have some proprietary support for React and some
Yes.
others.
correct.
I mean, React would be the obvious one for you guys.
Well, we've got some big implementations to React.
Cassandra's pretty good on write to report, but I'd be pretty nervous about MySQL and some of the other ones.
So the
kind of message rates you were
I
talking
agree.
about.
I agree. The question is, what is your volume?
Yeah.
If your volume is hundreds of thousands, don't try to scale. If your volume is, I don't know, millions, billions, then yes, you need React kind of solution. Correct. Does this more or less answer?
Yeah.
Any other questions?
Yeah.
Yes.
Before you showed on the load testing that in certain moments you lost messages.
Yes.
So two questions. What does it mean, lost messages? Did you really lose them? Or they were somewhere a backup or offline or something? And if they were lost, why did you lose them?
Okay. This particular scenario was run with the DynamoDB backend, which is a database provided by Amazon, and it has certain SLAs where you can push messages, but not more than, and this is the limit. So you basically buy, I want to be able to push this many messages per minute. And if you try more, those messages will be dropped. Or maybe there are some other network-related issues that made your query towards DynamoDB time out. And at this point, we will drop a message. Drop means not deliver to the user. Drop in this metric meant didn't manage to store it in the message archive. So we did deliver, but we didn't manage to store a copy. So it's still not good.
And if the guy would have been disgracefully disconnected, so the server thinks he's online but he wasn't, and you sent it out but he couldn't store, then it would have been lost?
No, because we have stream management. Stream management will give us feedback. Don't lose the message yet. Don't consider this delivered, because the guy didn't acknowledge receiving the message yet. So we will store it in the session process for some time, and then once this will time out, then we will try to store it in the message archive.
Again, hopefully then be able to store it.
Yeah. So, I mean, in a huge distributed system, we need to be ready to accept some failures. This is why we always have lots of metrics within the application which give us feedback about every aspect of the operations. How many users have logged in? How many users have sent messages? What kind of messages they've been sending? How many messages were not delivered? And so on and so on. So we have like hundreds of metrics being collected from a live system and accumulated with, for example, Wombat, which is...
What tool do you use to measure the metrics?
Wombat is a solution offering from Erlang Solutions to monitor Erlang systems and to collect metrics. For example, like this one from mongoose. Yes?
I was wondering, probably WhatsApp nowadays could be considered a leader in the chat room and in this sort of chat infrastructure. I was wondering if you consider your architecture similar to the one of WhatsApp, if you are aware of how the WhatsApp architecture is, and if you are aiming in that direction, this sort of question.
So we had the pleasure to work with WhatsApp at some point of time.
Cool.
So yes, we were sort of aware of what is it that they are doing. They are scaling to the numbers beyond the numbers I presented today.
Right.
So they adopted some other techniques like sharding and other things. They have a number of presentations given at the Erlang Factory conferences in San Francisco, where they explain more about their architecture, which evolves over time. So, for example, what we have seen some time ago might be not relevant to the way it is done today, because they are ever-growing service, and they need to solve new and new bottlenecks that pop up. So, I cannot say for sure what is exactly the architecture of WhatsApp as of 2015. I would recommend watching some of the videos captured during Erlang Factories in San Francisco, or maybe even contacting them. I don't know.
I was wondering where you stand comparing to them, and if there's
Yeah, so, I mean, it's not a secret that they also started more or less where mongoose IM started, which was taking eJabber and trying to adopt it for higher volume. And they've been doing a lot of optimizations that, for example, try to save on the traffic, which is sent from the mobile to the server side. So, like, get rid of XML as we know it, and try to be more efficient, almost binary protocols to ensure that every single byte that we can save is saved. Once this is multiplied by 500 million users, it actually gives you quite some savings. They've been optimizing the internals of the Erlang VM, where they found some issues within the, I don't know, garbage collector or something. They've been optimizing and publishing some patches to the Erlang VM, which for their use case scales better. Some of them were adopted, some of them are too specific to their platform, and they were probably not adopted. But still, they are engineering the system every day, and this means that this is ever evolving. Yes?
I think also they have the benefit of not implementing a standard. They implement a proprietary protocol tailored for their specific use case. So they, of course, can scale in a different way. They have different things there, and also they're doing one trick. They're never storing anything on their servers. Everything is in memory. The minute you have received the message, it's gone from their servers. So they don't have to have all these message archives or anything there. That has been the game until Facebook bought it. Of course, they're probably storing everything that goes through the system now and trying to make money off that. So that's a different story. But the original WhatsApp was not storing anything. It's just keeping it in memory until it had it delivered to the end client.
But to answer the other question, yes, we are aiming at big numbers. So we are working with our customers on their volume of traffic, which is tens of millions. WhatsApp is hundreds of millions. So it's an order of magnitude less.
They claim 700 million subscribers at the moment.
Yeah, correct. So we are working with customers of, with one level of magnitude less traffic, which still is a challenge. But this is more or less where mongoose IM is today. Those are the numbers that we are aiming at today. Any other questions?
So, what are the advantages of mongoose IM over eJabber? Why would I choose one over the other?
They focus on being very feature rich. They support quite some extensions that we don't. So if you have a need to have lots of different features, I would say eJabber might be a better option for you. However, we focus on high volume, scalable, and fit for mobile. So if your use case is mobile, lots of mobile clients, I believe we can offer a better experience than eJabber in terms of scalability and feature support, which is specifically supporting mobile use cases.
On the website, is there a list of supported clients? Because it's standard compliant to XMPP, presumably you're not writing the client code.
We are not
writing. Is there a list there of which ones you've tested and are known to work?
So we don't support any client library officially. We have experience with adopting some existing open source libraries, but it's not like we officially support any of them.
Yeah, I was thinking if somebody downloads an XMPP applet on their phone, they want to download one which they know Mongoose is known to work with.
Oh, if you're talking about standard XMPP clients, then it will work with any.
Okay, you're happy that it works with this. Yeah.
As long as it complies with standards, we will support any client. I thought you were referring to some libraries that you would use to implement your own solution. This has been tested with Adhering, C, Game, Jitsi, many different clients, and it works.
You're not getting any issues on iPhones. Apple appear to be putting a lot of restrictions now on pushing messages out to iPhones and trying to enforce people to go through their messaging system rather than push data out directly. You're not seeing any of that at this stage. I know some people have been impacted by that.
Well, WhatsApp would have a problem then, wouldn't it?
they're perhaps big enough that they can argue with Apple, but I know some smaller developers have had trouble that Apple wouldn't put their app in the store because they wanted to push their own content out to it, and Apple said no, you've got to go through our messaging service.
I'm not aware of any
stuff
such issues. Any other questions? Alright, I mean, I'm around, so grab the mongoose beer and we can talk about it. Thank you.